Hi, it's time for another math easy solution. Trying to discuss further into integrals and volumes by cylindrical shells, and now go over example 4 of the example series. I'm going to go solve this example, which says find the volume of the solid obtained by rotating the region bounded by y equals x minus x squared and y equals 0 about the line x equals 2. Yeah, now in this example we're going to be rotating about line x equals 2, which is different from my earlier videos, which I usually rotate about y-axis or the x-axis. So now with this one we could use cylindrical shells in this example, and I'll show you that in a bit. But first of all, so this function y equals x minus x squared, this is a parabola, and that's just you could tell by the power 2 there. And this one here, if we solve for the 0, so at 0 equals x minus x squared, this is true when basically x is either 0 or when we just plug in 1 here. So 1 minus 1, that's just 0. So basically at the zeros are right here and 1 right here. We'll call this 1, and now it's a parabola, and at small values less than let's say less than 0.5, x is bigger than x squared, so we're gonna be basically above 0 right here. It's gonna look something like this, or even basically when x is less than 1, it's always gonna be above 0. So it's gonna be like this. Parabola looks something like that, and that's how it looks like. This is actually curving down right there. So it's going to look something like this. It's symmetry. I'll just draw a better one. Okay, so that's a better drawing right there. So there's the region. It's bounded between this function right here, which is y equals x minus x squared, and y equals 0, which is just this flat line. So there's the region. Now we're rotating about the line x equals to 2. So that's 1. Then 2 would be basically right across here. So this is x equals to 2. So we're going to be rotating it about this line. So that's going to be, now we're going to have to draw a mirror image across to here. So it's going to look something like that. And now we're rotating, so when we could use this cylindrical shells method, yeah, and we're going to draw our shells the same as we've always been doing in my earlier videos. So we would just pick a random point here. This would be actually in between. So we'll draw a shell like this, or a rectangle. So at this point is x, so just a general point right there. The height of this is going to be, well, x minus x squared. That's just the height there, because we're dealing with y equals 0, where this is the horizontal line. So that's the height. I'll just highlight this right across. And now we're going to be rotating this about, so it's going to look something like this. This is just a, yeah, this drawing's not perfectly symmetrical, but it should be. And it looks something like that. And this would go all the way across. And there is our shape. It looks something, oh, this is behind it. This is a bit hard to draw. Okay, this would be actually see-through. The dashed line is the see-through part. So yeah, you get the idea. So then this part actually is going to be see-through, and now we'll see it right across here. So there we go. There is our shell. This looks a bit off. This should actually be a bit bigger. Yeah, but anyways, I'm not the best drawer. But so that, as you can see, we have a shell. Assume that these heights are the exact same. So now the radius of this shell would be basically from this point to this point, where this is x equals to 2. So this is, and then this point right here is our x. So what we're gonna do is just 2 minus our x. Yeah, because basically this full length is just 2. So we just 2 minus x, that's our radius. We know our height, and our thickness is just our delta x. So now we could write the volume integral as a cylindrical shell, and that would be just v equals to, from 0 to 1, that's again from 0 to 1 right here, of now 2 pi, and now this is the radius. So this is, we're getting the circumference of 2 pi times this 2 minus x, which is the radius. times it by the height, which is just our height of our shell there, x minus x squared, times by the thickness now, which is delta x, but in this case infinitely small delta x because we're using integral. So we get this right here. Now we could simplify this by expanding and taking the constant 2 pi out. It's from 0 to 1 of, now this becomes, we multiply this inside, etc., and add them up. We're going to get 2x, that's 2 minus x, minus 2 times x squared, 2x squared. Now we have a negative x times x, that's negative x squared. And now we have negative x times negative x squared, that's positive x3 dx. Now we can simplify this further by adding these two up, so we get 2 pi integral from 0 to 1 of 2x minus, these just add up, 3x squared plus x cubed, and now this is just our dx. Now we can just solve the integral. This is going to be now 2 pi, this integral of 2x, that's just going to be 2x squared over 2. Now minus this part right here, which is going to be 3x, 3 over 3, plus now we have this x4 over 4 from 0 to 1. Now we can just plug these inside, so 2 pi, plug this inside, this is going to be, well, these 2's cancel, the 1, this is going to be 1. These 3's cancel, put in the 1, that's just going to be 1 minus 1, plus again 1 over 4. And now we ignore the 0 because everything's just going to be 0. So these cancel, and we're going to be left with 2 pi times 1 over 4, which just equals to the 2's cancel there, pi over 2. And that is our final answer. Anyways, that's all for today. Hopefully you learned from this example, and thanks for watching. And also, like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.